Hey, we're back. Hello. And moving on back here to our roadmap. We left off here at a dead end, made our bicyclic enamine, and we're now going to complete this wraparound here. And what's going on here? Okay, this is another one, another staple reaction that's almost on every test. What is the most reliable way to convert an alcohol to an alkyl chloride? And don't put HCl there. You get 0 because that one doesn't work at all. This is the one where you use SOCl2 and pyridine. PYR is an acceptable short form for pyridine. Step 1 over here is going to make the alkyl Grignard. Call that R, I don't know, RY. RYCH2 to an MgCl. That's a Y. And then that's going to attack on this carbon here, which is a nucleophile. Nucleophile here, C- attacks ethanal. Ethanal is a 2-carbon aldehyde, also known as acetaldehyde. You're going to get a new bond. So your RY is attached to a CH2, new bond to a carbon with an O-. Don't draw O-, draw O, and carbon. O- in step 3 becomes OH. And that matches up perfectly with this, and it seems to me we're getting points for doing the same thing over and over again. Secondary alcohol becoming a ketone. We did one down here somewhere. Where'd we put it? I don't even know. We used PCC sometime. There it is. Secondary alcohol became this ketone. Primary alcohol became an aldehyde, same chemical, PCC. It's a good one. Let's use it. PCC, got 3 points for it so far. And then we have a ketone that has a carbon with 3 H's on it. And you see that combination of that's an acetyl group. Don't get confused with acetal. Acetyl group is CH3 attached to carbonyl. And we have a test for acetyl groups called, in this case, the bromoform reaction, which will take the carbon here and it'll end up with 3 bromines on it. The acetyl CH3 is now an acetyl, sorry, it's not an acetyl at all. Br3 attached to the C that used to be the acetyl, and it picks up an H during the mechanism at the end. That's bromoform. It's got 1 carbon in it. And that's a B, terrible B. And the other 7 carbons must be everything, including the carbonyl, 1, 2, 3, and cyclobutyl. We called the cyclobutyl with 1 carbon, the RY. That's 5 carbons. And that's that, and it's attached to 1 more carbon, 6, and the 7th is the carboxylic anion, carboxylate. And the minus is kind of far away there, isn't it? Carboxylate. It gave up its proton to bromoform, and that would be a precipitate. All right, and it looks like it's pretty popular to react carbonyl compounds with secondary amines. We did it down here. Carbonyl compound with a secondary amine made an enamine. Here, you're going to make an enamine. And where do you make the ene? I reminded you, and I want you to remind me now. You can hit pause and remind yourself. Coming back after pause, you've got the double bond between the carbonyl carbon and an alpha position. That's one of the products. That's the minor product, because the double bond would be fairly unsubstituted. If you went from carbonyl to the other alpha carbon for the other ene, you would have the major product. And that goes like this. And C, R, Y. And that is a nitrogen here in a ring, size 5. And don't forget the methyl. And here we have RY. Goes to the carbon, double bond on the less substituted carbon. And that was an enamine forming reaction. Major is more substituted, minor is less. And there's a dead end there. Nice. How did we get here? We stopped before we got there. Let's round the wagons back. Lithium aluminum hydride reduction of aldehydes and ketones makes alcohols. So you're going to copy everything you have here. Carbonyls are now single bonds to OH. R prime. OH. 1, 2, 3, 4. Single bond OH. Ethyl. There we go. I'm beginning to think that acetals and hemiacetals are very important, and especially when I'm told they're important. It's one of the most fundamental things in this course, not just this test. So yeah, we're going to make 2 different hemiacetals, and then they're going to converge to make one. I didn't put acetal up there, but I'm hoping you understand it is. Notice the absence of DST up here because the condensation step isn't till after hemiacetal. It's to make an acetal. And both of these will make an acetal. So what's the deal? Hemiacetal 1, hemiacetal 2. Well, cyclopentanone, we can draw that to stall for a little time. Either alcohol can attack that to make the hemiacetal. Both hemiacetals will have the cyclopentyl and an OH. New bond from the other alcohol. And if you chose to use this OH to make the hemiacetal, then you'd have this structure here. O goes to CR prime. And the O also had a butyl. And this went to a C with an OH and an ethyl. And if you chose the other one, the O here is attached to a C with an ethyl. Same C has a C goes to R prime. And that C goes to an OH, COH, and a butyl. And then you need another alcohol, which we have in both molecules, another alcohol, and this will go away as water. And what are you going to end up with? This O that's here will end up on this carbon, which ends up being the same product as this O here on that carbon. Verify that in your own time. It doesn't have to be a pretty drawing. Just remember, both the red O's are going to end up here. I'll go from this one because they're right above and below each other. Let's say this O was this O. It's attached to a C, and I'm going to make sure I end up with this O here. So the O is attached to the C. I'm going to bring that up R prime. That's an R. So that's up. And then the C with the R prime had a C. C with the R prime had a C. That went to the C with the OH. It has an ethyl on it. And the butyl group, this O, attached to a C with a butyl. There's a butyl in here too. I wrote boo right there. O attached to C with a butyl. O attached to C with a butyl. The C with the butyl is attached to a C with an R prime. The C with the butyl is attached to a C with an R prime. The C with the R prime is attached to a C with an O. The C with the R prime is attached to a C with an O. Whoa. C. Is this an extra C here? It seems to be an extra C, doesn't it? How do you fix that? That's a good question. It seems like we have an extra C in here. I hate having a bond that bends. Oh, that's an eraser. That's no good at all. But I would accept that. We can just, try to make it clear too. Put an A and a B. An A and a B. And the C with the R prime is the A. And it goes to B, which is the C with the O. A is bonded to B. I think I just made a mess, but that's okay. The answer key is much neater, I believe. Okay, and what do we have going from here to here? Or should we stay on this track? This track's over. This is a dead end. We're going from here to here. What's a change? Oh, the only change that I see, everything's the same here on the bottom. And this C is the same, and we have a double bond from here to here with an alcohol, losing an OH on one carbon and an H on the next carbon. That's called acid catalyzed dehydration of an alcohol. That's a good review reaction, isn't it? And we accomplished that using sulfuric acid and heat. And then we're going to make an epoxide. Favorite epoxide. It's nice to have dangerous epoxides in lecture courses. Peracetic acid. It's good per acid to make epoxides. There's other ways to make epoxides. And that's that. And down here, we're using diazomethane. That reacts with alkenes to make cyclopropane. You want to review chapter 15 for that one. We may have labeled this already. Yeah, that's already R on the left of the screen. Yes, nice. R bonded up to C, 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 C. And you can put your little cyclopropane right here. So that double bond has a cyclopropane. I need reagents that convert my R group back to a carbonyl. If you get this to be a carbonyl, you will be up to here in this molecule, if that's an aldehyde. And that'll be an aldehyde. You know how I know it'll be an aldehyde? Well, it's got an H here, it's got an H here, and it's in here, it still has the H. So H attached to a carbonyl How do you know that used to be a carbonyl before it was an acetal of the sulfur variety? Well, it has an H there. So we're going to take advantage once again of this H. This H having a pKa of 30. We're going to take it off from our R group down there. That H is in here. KH is a good way to go. Pen is off. H is off. What's the new bond right here? The new bond is from carbon to a carbon that has an O. Not carbon to a carbon adjacent to a carbon with an O. Carbon to a carbon with an O. That means you attacked an aldehyde. The anion made in step 1 attacked an aldehyde of this variety. And that would make an O minus. Step 3, the O minus needs to become OH. And now I'm going in 2 different directions here. Very popular thing for chemists, organic teachers to test. Can you make this OH into a ketone? It's already on this page 3 times. Can you make the carbonyl into an alcohol? It's already on this page once. And let's go with the one we've done multiple times. Oxidation to a ketone using PCC. And I think we could be able to squeeze that down here. When we're ready, we'll be able to use some short forms to get this to be down here. Reduction of a ketone to an alcohol. How do you know it's reduction? Well, I'm replacing a bond from C to O with a bond from C to H. There's a new CH here. And a bond from O to H. H is less electronegative than C from oxygen's perspective. H is less electronegative than O from carbon's perspective. You can use the one with H2PT and pressure if you want. You can use sodium borohydride. Followed by HCl. Reminder, those are an or proposition. They both will reduce ketones and aldehydes to alcohols. And just in case you forgot, the most important thing on this test is forming acetals. Here it is again. Acetals require a carbonyl, such as that found in acetone. They require 2 alcohols, such as those found in this molecule. So we do not have to circle this, I do not have to draw this thing over here. I believe we've never short formed that yet. RZ. So RZ is attached to a carbon that has an O, attached to a carbon that has an O and an isopropyl. And the O's both end up attached to the carbonyl, which loses its O into here. So let's even circle. Let's make it red. And red, that's where the O goes from the aldehyde and ketone. And you make new bonds to acetone. Acetone has dimethyl right there. There. And you've got that acetal. And we also know how to make secondary amines react with aldehydes and ketones to make enamines. And I think this thing we circled here is also found up here. RZ's on top. Let's put a dividing line in here. And we have RZ on the top. Still going to be a little tight. RZ goes to a carbon that is a nitrogen now with 2 methyls. Next door carbon also had a carbonyl, so it's a nitrogen with 2 methyls. It had nice propyl on there too. Nitrogen with 2 methyls. And no, I have not forgot you need to make enamine. Enamine has to be, oh, this is where we have trouble. I have to make my double bond into my RZ. It needs to go here. It means RZ is no good. I'm sad. I know, you were sad a little while ago. Yeah, that has to be an enamine. You're saying, why don't you just make the double bond here? Well, then you can't have an enamine here too. So the double bond is here. Double bond. And that is to here. And we have, that was our prime, I believe, the cyclobutyl by itself. And we need something else. Our upside down U. And we have a double bond here as well. Enamines. Double bond from the carbonyl carbon to an adjacent carbon. Double bond from the carbonyl carbon to an adjacent carbon. Got excess of its secondary amine. You need to make 2 enamines. And wow, I know we're going long, but you know, we're almost done. Yeah, 1 box. It's been epic. We should have done this one when we did this one. They go together, don't they? So you're going to make us, did I finish with that one? Yeah, I did finish with that one. It looks like it's got the same thing down here. Oh, we got the labels here. Let's just use them. R prime, R double prime. And where does that get us to? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And where's your cyclopropane this time? Where the double bond used to be. And here it is. But this time you got 2 chlorines. Off of the carbon here. You might want to review that mechanism where we made a carbene from chloroform. Okay. And that is the end of this segment. It was epic. Now, guys, I've had a lot going on today. Some of you sent me emails for other review items. I just need you to do this now. By the end of break, remember what your good question was and just unmute yourself and ask me to do a specific problem. Or how about right now? So I can get it ready during break. That's a better idea. So I know some of you had good suggestions and I'm just swamped right now. And it would be faster for us if you could just tell me which exam you wanted to do a question from and what question it was. Otherwise, I'll just wait till after break and we'll find something.
I have some questions.
Sure, let's do, you got one that's short or one that could do a whole segment? Well, let's assess that when we hear it. All right.
It's from the multiple choice questions. This is Winter 2020, part 1.
Winter 2020?
Yep, part 1.
Part 1. And which questions did you like? Was it one of those ones that's a set of questions?
Like, yeah, if you can do the multiple choice, like from 7 and up.
7 and higher. 7 and higher. All right, I'll get those loaded up and we'll tackle some of those. That definitely sounds like a complete segment right there. All right. And then we'll see what we have left for time. We'll probably have time, and then we'll do something else at the end of the other break. All right, so I shall see you guys and take care.